Welcome to Beyond Buzz. Imagine hurtling through the endless blackness of space, surrounded by a silence so profound it feels almost otherworldly. There is no up or down, only the infinite void stretching in every direction, and the faint hum of your spacecraft's systems is the only reminder that you are not alone in this cosmic sea. You are traveling farther from the sun than humanity has ever dared, venturing into the cold, dark reaches of the outer solar system, where sunlight is just a distant memory and the warmth of home feels impossibly far away. For 5 long years, your tiny vessel has voyaged in utter silence, gliding past the orbits of Mars and Saturn, alone among the stars, carrying with it the hopes and questions of an entire planet. Suddenly, a bright star on the horizon grows ever larger, swelling until it fills your entire view. Jupiter, the king of planets, looming like a cosmic colossus. This is no ordinary planet. Jupiter is a true giant, so massive it could swallow every other planet in our solar system and still have room to spare. Its gravity shapes the fate of moons, comets, and even the paths of asteroids. Jupiter greets you with a breathtaking symphony of swirling, chaotic colors, colossal storms and bands of clouds, each more vibrant and violent than the last, painting a masterpiece of turbulence across its face. The great red spot churns relentlessly, a hurricane larger than Earth itself, raging for centuries with winds that could tear apart anything in their path. It is a storm so vast it could swallow our entire world whole. Lightning flashes in continent-sized sheets, illuminating clouds of ammonia ice and casting eerie shadows across the planet's ever-shifting surface. These storms are more powerful than anything seen on Earth. Against this backdrop, your spacecraft is a mere speck, dwarfed by the cosmic giant, about to plunge into the unknown depths of Jupiter's atmosphere, where no human has ever gone. Jupiter spins faster than any other planet in the solar system, completing a rotation in just under 10 hours. This rapid spin stretches its clouds into bands and fuels violent jet streams that race around the planet at breakneck speeds. Our robotic emissary, Juno, prepares for its first daring dive, bracing itself against a relentless tide of deadly radiation. Radiation so intense it would destroy unprotected electronics in moments. Jupiter is surrounded by a vast magnetic bubble, a force field millions of miles wide, powerful enough to trap charged particles and create dazzling auroras at its poles. This invisible shield is both a protector and a threat. This is not a gentle giant, but a beautiful, terrifying force of nature, a planet of extremes, where beauty and danger are forever intertwined. We sent Juno not just to admire Jupiter's majesty, but to answer a fundamental question that has haunted astronomers for centuries. What lies beneath those violent, ever-shifting clouds? To truly understand Jupiter, we had to be bold. We had to dive in, risking everything to unlock the secrets hidden deep within the maelstrom. Jupiter has always been the archetype for giant planets, a colossal world that has fascinated astronomers for centuries. Its sheer size and swirling storms have made it a symbol of mystery and power in our solar system. It was the first planet to form from the sun's leftover gas and dust, emerging from the chaos of the early solar system as a massive, swirling sphere. Its immense gravity hoarded the solar system's original ingredients, pulling in vast amounts of material and shaping the destinies of other planets. In this way, Jupiter became a time capsule, preserving clues about the solar system's birth. To understand Jupiter's core is to read the first chapter of our cosmic story, unlocking secrets about how everything began. For decades, scientists believed a small, dense, solid core of rock and ice lay at Jupiter's center, hidden beneath its thick clouds. This core, they theorized, would have seeded the planet's formation, pulling in hydrogen and helium from the surrounding nebula and growing ever larger. But this was just a model. No one could confirm it, because the pressure deep inside Jupiter is unimaginably intense, making direct observation impossible. Jupiter's atmosphere exerts tens of millions of times Earth's surface pressure, crushing hydrogen atoms together until they become a strange liquid metal. This metallic hydrogen is what generates Jupiter's enormous magnetic field, the strongest of any planet in our solar system. The planet's dense clouds and powerful magnetic field created an impenetrable shield, hiding its heart from our view and protecting its secrets. We couldn't send a probe to the core. Any spacecraft would be crushed instantly by the overwhelming pressure and heat. For decades, Jupiter's heart remained a blank space on our map, a question mark at the center of a giant. We needed a new way to see the unseeable, to peer beneath the clouds and unlock the mysteries hidden deep within. A mission had to fly closer than ever before, equipped with instruments sensitive enough to probe the planet's secrets from afar, using gravity, magnetism, and radio waves as our eyes. We needed a hero for this story. We needed Juno, the spacecraft designed to finally unveil Jupiter's hidden heart and solve a decades-old mystery. The journey to Jupiter isn't a straight shot, it's a complex, carefully choreographed dance through the solar system, requiring patience, precision, and a bit of cosmic luck. Launched in 2011, Juno's path was a cosmic game of gravitational billiards. Instead of heading directly to Jupiter, the spacecraft first looped around the inner solar system, using the planets themselves as stepping stones to build up speed. In 2013, it swung past Earth for a gravity assist, flinging it toward Jupiter. This maneuver, called a gravity slingshot, gave Juno the extra velocity it needed to escape the sun's pull and set course for the giant planet. Juno is a solar-powered pioneer with 3 massive solar panels, making it the most distant solar-powered spacecraft ever. These panels stretch out like wings, each one longer than a bus, capturing every possible ray of sunlight. Out at Jupiter, sunlight is faint, just 4% as strong as on Earth. But these arrays power Juno's instruments, keeping the spacecraft alive and its science tools running. After 5 years and 1.7 billion miles, Juno arrived on July 4, 2016. The long journey tested every system on board, pushing the limits of engineering and endurance. It performed a dangerous engine burn to be captured by Jupiter's gravity. Success meant a revolutionary mission. Failure meant being lost forever. The stakes couldn't have been higher as Juno braked into orbit, threading the needle between triumph and disaster. The signal came through. Juno had arrived. Cheers erupted at mission control as confirmation reached Earth, traveling across hundreds of millions of miles. Juno's orbit is unique. An elongated path that swoops close to the cloud tops, then swings out to safety. This looping trajectory keeps the spacecraft away from Jupiter's intense radiation belts for most of its journey. Each close pass, or perijove, is a frantic 2-hour data sprint from pole to pole. During these flybys, Juno races just a few thousand miles above Jupiter's swirling clouds, gathering as much information as possible. Instruments blaze, capturing unprecedented detail. Cameras, magnetometers, and spectrometers work in unison, revealing Jupiter's secrets layer by layer. Then Juno retreats to deep space, processes data, and beams it home. Each transmission is a treasure trove for scientists, packed with discoveries waiting to be decoded. This cycle repeats, each dive bringing us closer to Jupiter's secrets. With every orbit, Juno risks the dangers of radiation and distance, but the rewards are immense. Juno's mission is a series of daring, high-stakes encounters. Each approach is a test of technology and human ingenuity, pushing the boundaries of what's possible. Each one rewrites what we know about the king of planets, peeling back layers of mystery and revealing a world more complex and beautiful than we ever imagined. Cameras alone couldn't solve Jupiter's mysteries. Juno needed to sense the invisible. The key was gravity. As Juno flies, Jupiter's gravity tugs, subtly changing its speed. Juno's gravity science instrument uses radio signals to detect these tiny shifts, mapping the planet's interior. The magnetometer, mounted on a solar array, maps Jupiter's colossal magnetic field, revealing the hidden ocean of metallic hydrogen. By studying the field's shape, scientists learn about the core's size and dynamics. The microwave radiometer, MWR, peers beneath the clouds, measuring heat from deep within. Different microwave frequencies penetrate to different depths, creating a 3D picture of Jupiter's atmosphere. The MWR reveals weather systems and circulation patterns connecting the visible atmosphere to mysterious layers below. Together, these instruments let Juno see what no camera could. They turn invisible forces into a map of Jupiter's hidden heart. Juno's toolkit is a triumph of ingenuity, designed for a world unlike any other. With each orbit, it peels back another layer of Jupiter's secrets. Juno's first data upended decades of theory. Scientists expected a small, solid core, but Jupiter had a surprise. The core is not compact but large and fuzzy. Heavy elements are mixed with hydrogen, extending nearly halfway to the surface. There's no sharp boundary, just a gradual, messy transition. This suggests a dramatic event, perhaps a colossal collision with another planet early in Jupiter's history. The evidence is in the core's diffuse nature and the uneven distribution of heavy elements. Jupiter's heart rewrites the story of planetary formation. The king of planets may have become king by violently consuming a rival. Exploring Jupiter is a dance with destruction. Every 53 days, Juno dives close, braving the solar system's harshest radiation. Jupiter's magnetic field traps high-energy particles, creating a deadly environment. Juno's titanium vault shields its electronics, but radiation still takes a toll. Over time, the spacecraft's solar panels degrade, a reminder that the mission is racing the clock. JunoCam captures breathtaking images of polar cyclones, storms thousands of miles across, swirling in stable patterns. Each perijove is a high-speed dash, gathering science as Juno skims the clouds at over 130,000 miles per hour. Then it escapes, carrying precious data. The mission is a series of daring sprints, each one revealing more of Jupiter's magnificent, terrifying world. Juno's journey is a testament to human ingenuity and courage. Jupiter's fuzzy core doesn't just solve a mystery, it opens new ones. The old model of planet formation is now just one possibility. Juno's evidence points to a violent dynamic process, with giant impacts shaping worlds. This changes how we see not just Jupiter, but thousands of exoplanets across the galaxy. The early solar system was a chaotic shooting gallery, not a gentle ballet. Juno's microwave radiometer revealed that Jupiter's weather patterns extend deep below the clouds, defying expectations. A massive ammonia plume at the equator challenges our understanding of giant planet atmospheres. The most exciting discoveries force us to rewrite the textbooks. Juno has given us a new blueprint for gas giants, complex, dynamic, and mysterious. Its data will fuel new theories for decades to come. Why care about Jupiter's core? Because its story is part of ours. Jupiter's gravity has shielded Earth, shaping the solar system and protecting life. Understanding Jupiter's history helps us understand our own origins. Exploration is in our nature. Missions like Juno push boundaries and inspire wonder. Juno's discoveries belong to everyone, fueling curiosity and innovation. Its images are cosmic art, reminding us of the universe's beauty and mystery. Each finding connects us to the wider cosmos, revealing the laws that govern all worlds. Studying Jupiter helps us understand planets everywhere. Juno's journey is a reflection of our quest to comprehend the universe. In Jupiter's secrets, we find a mirror for our own place in the cosmic ocean.